the stream, like I say, to where hopefully you can go back and watch the video of the class. Even if you came to class or if you missed class, you can watch it in real time. But you must have a Google account. That's one of the things. All right. So hello, how y'all doing? What's up, Mr. DeLay? We got to do a reinstatement form for you, right?
Yes, sir.
Uh-huh. All right. So where you been, man?
I registered late.
Huh? No, you wasn't. You was in my class. I saw you on the list. I saw your name on the list.
I registered at Friday. I wasn't here for the first class. I missed that Monday.
Right, but you was already registered in the class.
Yeah.
Right. Huh? Hello?
Yeah.
What are you trying to tell me, class? Huh? Trying to get over on me?
No.
Uh-huh. I didn't register. I wasn't registered. Yes, you was. Okay, so now, what we're going to do, we're going to go over our notes, all right? Our notes is in the first chapter is the introduction, all right? What we're going to do, we're going to take tests chapter by chapter, okay? We cover a chapter, we're going to take a test. Everybody understand that, right? We complete a chapter in the mid part of a lecture. What I'll do, I'll announce the test for the next class period, but we're going to carry on with the next chapter. Everybody got that? Okay. All right. So, chapter 1. All right. Introduction. Now, how many people in computer science? Okay. You all have your how would I say, your degree as computer science, right? Okay. Everybody else, what's your major? That's not computer science. Engineering, what else? So it's either computer science or engineering? Hello? Right? Right? Y'all quiet today. What's the problem? I know it's wet outside or whatever, but we in here. We dry. Why we ready to work? Right? Hello? All right. So let's look at the chapter introduction. All right. This chapter pretty much just deals with the general information about computers and what they do, all right, and how they work, all right. If you look here, it says think about some different ways that people use computers, all right. What are some ways that we know computers are being used? Phones, the cell phones is like a computer. What else? Huh? Games. What else?
Research.
Huh?
Research.
The who?
Research.
Research. What else?
Space travel.
Space travel. What else? Huh?
A lot of stuff.
A lot of stuff. What's a lot of stuff? Like?
Everything.
Huh? Banking, right? Detective work, right? Teaching, right? Even in your home, you have what? Computerized stoves, microwaves, etc., etc., etc. Right? So computers are pretty much used almost in every aspect of what? Our lives. Correct? All right. So, I thought I turned it on. Battery did. All right. So now, so if we look at it, in order for computers to work, they have to be what? Huh? Programmed, right? So when you're dealing with programs, you have to write what? You have to use software to write those programs, right? And those programs become the software that drives whatever device that you're using, correct? So hopefully you in this class will become what? Programmers, right? You're gonna be the person who designing the software applications to what? To manage a particular device, right? Because if we look at a Coke machine, what are some of the things that are done with the Coke machine that you think is computerized? When you press a button, right? It has to know what button you press. Also, when you press that button, it has to know what?
Which thing to choose.
What selection, right? What else? How to navigate, what else? How much it is, right? Because it can, just because you put something in the machine and you press a button doesn't mean you get anything out, right? If it's not enough, what? It won't give you anything, right? But then if it's equal to what that you selected, it's gonna give you what? The item that you selected. What if what you put in is more?
Give you change.
It's gonna give you change. So you see the things that happen just with a Coke machine, right? That's computerized. Now some of them would display what? I've inputted what? $1, $2, etc. Right? Correct? So it actually communicates with you as you work with it. Correct? So you as the programmer would be writing code to determine what? $1 is whatever. Then 50 cents added to that dollar is $1.50. If the item costs $1.25, you would be writing the code to subtract to see if what? There is an overflow, right? And if there is, then you would what? Give them that item, and then what? Then actually give them say that they're owed X amount of change, right? But now the engineers are the ones who actually work with the mechanisms and whatever, and how it works and whatever, to select and whatever and stuff like that. Designing it, right? And stuff like that. Correct? All right. So hopefully you'll be the programmer or software developer, all right? So dealing with computers, you have hardware and you have software. The software is what's used to what? Manage the hardware, and the hardware is the what? Physical equipment, right? Just like a printer, that would be what? Hardware. But the software that is what? Used for the computer and printer to understand one another is what? I said it, It's software, right? Right. So, and normally that would be a printer driver, right? Normally they call them drivers, sometimes they call it firmware, etc. Okay? So, the hardware refers to the physical components of the computers. Who can name some of the physical components of your system? Now your system, we normally look at the entire computer as a system where we're looking at everything, but the system would just be the box where the hard drive is housed, right? So what would be some components that would be added or connected to your system?
Graphic card.
Huh?
Graphic card.
Yeah, right. You can say graphic card, but that's internal. What else?
CPU.
Huh?
CPU.
Yeah, CPU is a component of the computer. It's within the computer. All right?
Mouse.
I'm talking about attachable component. You got the mouse, monitor, keyboard, printer, right? Speaker, microphone, right? Modem, right? Your camera, right? All those would be the devices that you can add by USB or whatever kind of connection, so that what? It can communicate with what? That computer, right? And it becomes a component of that computer. All right? What's that? All right. Now, all right, so if we look here, all right, it tells us about the major components of, all right, of a computer. The CPU, which somebody mentioned, that's internal. The CPU, bless you, is where all of the instructions are executed. Okay, all your instructions are executed within that CPU. How many people have bought a computer? All right, and it tell you about the processor or the CPU speed, right? That's how fast it can what? Execute X number of instructions. All right. Right? So normally, not always, the more instructions that it can execute in a certain amount of time, the what? The faster your what? Your system or your processor is. Right? All right? So the CPU is broken down into two components: the arithmetic logic unit and the control unit. Arithmetic logic unit is where all the math processes is done, and then all the other instructions are executed in the control unit. Now, the computer can only understand what?
Machine language.
Huh?
Machine language.
Which is? Which is? Which is?
0, 1, 0, 0.
Zeros and ones. Binary, which is correct, but that's dealing with what? Zeros and ones. That's the only thing the computer understands. If it's a picture, we see an image, but the computer sees what? If it's music, the computer, we hear sound, but the computer reads what? If it's a document, we see the document, but the computer reads what? Zeros and ones. So everybody understand that the computer can only understand zeros and ones. All right? Okay? So then we got main memory, which is a component of the computer. And main memory would be our what? Huh? RAM. What RAM stands for? Random access memory. Now, what does that mean? What does random access memory mean? We say it.
Only there for like, as long as the computer's on, like, we switch it over.
Okay, that's one characteristic of RAM. What Mr. What? Mr. Santos says, as long as the computer is on, your RAM memory is available to you. That is true. What is RAM? How does RAM work? All right? Random access memory. What that mean? That give us the ability to do what?
Store stuff.
Huh?
Store stuff in.
Huh? Run. He's right, but I want a little bit more. Run what?
It's like different
Things, right? Multiple things, right? Random access memory allows us to run Windows and run Windows the operating system, run Word, run the internet, run a graphic application, etc., etc., etc. As long as I have enough what? RAM to load it. And then I can switch what? Between each one of those applications. Random access. Right? Everybody understand it? Now, the thing is with RAM, in order for me to run an application, it must first be able to be loaded into what? Huh? It has to be loaded into what? Huh? Well, it has to be processed to that, but it has to be loaded into what? That's true, but we're talking about what now? RAM, right? So it has to be loaded in the RAM so it can be resident for you to what? Use it. Yeah. So if a program or an application is too large to fit in the RAM, what happens? It might, your system might shut down, or you might get this error saying that your memory is very, very low. You may need to free up some memory, whatever, right? So, like I say, your RAM memory, all applications that you run, depending on the time you run them and how many of them you run at a time, has to be loaded in the RAM in order for you to use it. So if you got limited RAM space, you have limited what? Files or applications you may be able to execute. So that's why it's important when you buy a computer from the store, you consider what? The RAM size, right? Because you don't want to be limited. You buy the computer, it works fine. Then you start saying, oh, I need this application. I need this application. I need this application. Then when you buy the fourth one, it's like, oh, too much memory. You know, and all of a sudden now you're looking for a bigger and better computer, right? All right, so that's an important thing to consider. Secondary storage devices, what are those? Flash drive, what else? CDs, DVDs, external, hard drive, internal or external, right? A second, floppy disk. How many people know about a floppy disk? Oh, okay, so we have a lot of people know about floppy. Floppies come, I think floppies somewhat was fading out back in the early 90s, somewhere around that time. And once the USB mouse came out and whatever, all of a sudden, then it came out with the storage, USB storage, and it kind of got away from the
Zip drive, Dr. Flop.
right, yeah. See, 'cause you had the 5 1/4, 3 1/2. Then you went to the zips. The zips held more information, but they were bulky and whatnot. You couldn't put them in like a shirt pocket or pocket or whatever. And then they came out with the jump drive, and like everybody was like going crazy then, right? And then you held more information. And then they started getting larger and larger. Cause what? Most of the jump drives that they was creating at the beginning was larger than the hard drive that was on the computer. You know, so and eventually, like I say, your jump drive, they got larger, but then your hard drive became larger also. All right. Input devices. So we talked about all the different storage devices, the main memory, CPU, but the components. When we talk about components, that attackable components, those components can be classified as input or output devices. So what's an input device? Would it be considered an input device?
Touchscreen?
Huh?
Like a mouse,
Okay, and what that mouse does? Allows the user to navigate, okay. But to what? What you doing? What you actually doing? Putting information into the computer, all right? So an input device allows a user to send or put information in the computer, because when you're using a mouse and you have a button and you might have a question prompt, are you sure you want to continue? When you click on that button, it sends the program some information, in the computer, and the computer uses it for that program, and then it then perform a particular task. All right. What's some other input devices? Microphone, because you're doing what? Right, you're speaking into it, and the system receives that information. What else?
Keyboard.
Webcam, keyboard. What else? What's a common one we somewhat overlook? How many of you have a cell phone? What's the input device?
Touchscreen?
The what?
Touchscreen?
The touch screen,
That's what I
right?
heard.
So the screen on a computer, if it's touch screen, is input, and definitely on most of the newer phones nowadays are what? Touch screen, correct? So the screen is an input device, but the screen is also a what?
Output device.
Output device, right? Okay.
Fax machine be considered an input device?
Who?
Fax machine, since it's input.
Yeah, it's kind of like a scanner, right? They use that scanner, camera, yeah, stuff like that are input devices, right? Okay, but then output devices. What are output devices?
Monitor.
Devices that allow a user to do what?
Receive.
Receive information from the computer, right? Whether it be what? Hard copy, right? On the screen, sound, etc. So what are some output devices?
Monitor.
The who?
Monitor.
Monitor, printer, speakers. You got me? So those are somewhat output devices. Allow you as a user to receive or get the information back from the computer. All right? So if we look at this chart here, this just a chart showing you the different components we talked about. You got your CPU, you got your main memory. Notice the RAM, normally your RAMs are on, they call these, on here, SIM chips. All right. Normally, depending, and you could change them out on your computer, but you have to match your RAM with your computer. You can't just go buy RAM or take RAM out of one type of computer and put in the other. It'll fit most times, but you have to have a RAM that's compatible to your system. All right. The CPU, if you look at the top, that's the CPU. All right. Up here, that's the central processing unit. You can't see it on this computer here, but if you see this fan, that CPU sits behind that fan. Now, why you would think that the CPU would have a fan sitting on top of it? Overheat. Because what? The more or the faster the instructions are executed, the what? More heat is generated, right? So the system does have to what? Try to reduce that heat. Now, there's also, and you can't really see it, it's like an aluminum braille, all right, which is a heat sink. And what it does, it absorbs the heat, but it doesn't hold it. But it'll absorb a lot of the heat from the system. And most systems have multiple heat sinks so that it can kind of cool down the system. If you have a laptop, more than likely you won't have those heat sinks in that fashion, but you may have a copper bar, all right, that goes along the base of the laptop, and it draws out the heat. Now, they can somewhat go bad, because over time, like I say, depending on how you use your system, how many people have a laptop, you're always setting it on the bed or whatever, and then over time, what? No matter what you put it get hot, right? That's because your heat sink then somewhat went bad because you done overworked it in a sense, all right? So you gotta watch that when you're using the laptops and whatnot. But this is just a design showing input devices, output devices, and then here's secondary storage, which could be what? That's a hard drive, could be floppy, CD, DVD, whatever, right? Okay? Any questions? Anybody with any questions? All right, so here it just talks about the CPU and how the CPU works. And we pretty much talked about it and says it's called Central Processing Unit and pretty much what it does. You can read through it. Now, if you look at this, it's just showing you a computer and the size of that computer, but then it's showing you here a process, this particular photo, showing you this microprocessor, and this little microprocessor can do way more work than this particular computer was able to do back in the day. But at that time, it was sufficient, right? Nowadays, what? We want information like that, right? So it's a little different. Like I say, nowadays these type of computers would work, but they would be so slow in retrieving information. Then too, the person that works on, now when I say work, operates this type of computer, pretty much have to know that system inside and out. And what I mean by that, you don't see a GUI or graphical interface, oh, just click this, oh, just type this. You have all kind of wiring and buttons and whatever that you have to know exactly what you're doing, or you could what? You could really mess something up. So back in the day, most computer operators were engineers or whatnot, right? So they were the type people who actually, or mathematicians who actually operated the computer. But nowadays, we got what, 15-year-olds doing a lot of things by just learning it from the internet and whatnot, right? Because they done made it so easy to do and develop software. All right? All right. And we talked about the main memory, and this is this SIM chip, and we talked about that it was volatile. Mr. What? Santos. He said that as long as the computer on, that the RAM memory is there. But once you turn it off, which we talked about being volatile, that means it's gone away. So it's used as long as the computer is turned on. When the computer is turned off, it's wiped out. How many people have pretty much have a desktop and you just leave it on for maybe 6 months to a year? Just go use it and just leave it alone. How many people do that? Huh? Nobody?